In this problem, we need to verify the following identity. The sine of theta times the quantity, the tangent of theta, plus the cotangent of theta equals the secant of theta. Well, in verifying identities, we nearly always want to start with the more complicated of the two sides. That's very easy to tell in this case because the left-hand side is definitely more complicated than the right-hand side. So I'm going to start with the left-hand side. But before we do that, it's always a good idea to look at what we're trying to prove. We're trying to prove our expression equals the secant of theta. And hopefully you've memorized some of the basic identities. And the secant of theta is 1 divided by the cosine of theta. Looking at the left-hand side, I don't see any cosine thetas here at all. So this might be one in which we need to write every trig function in terms of sines and cosines. So in order to do that, remember the two ratio identities. The tangent of theta is equal to sine theta divided by cosine theta. Cotangent of theta is cosine theta over sine theta. I could immediately write the tangent of theta and cotangent of theta in terms of sines and cosines, but I prefer to distribute in my sine of theta into the parentheses before I do that. So I'm going to get the sine of theta times tangent of theta plus the sine of theta times the cotangent of theta. Now I'm going to use my ratio identities, and since those are fractions, I'm going to turn the sine of theta into a fraction by dividing it by 1, multiplied by the tangent of theta, which is sine theta over cosine theta, plus the sine of theta over 1, times the cotangent of theta, which is cosine theta over sine theta. First term, nothing reduces, so just multiplying across. Sine theta times sine theta is sine squared theta over 1 times cosine theta is cosine theta, plus, now in my second term, the sine of theta reduces, and I just get left with cosine theta over 1. Looking at the right-hand side, I only have one term. I have two terms on the left-hand side. I'm going to have to add them up. Since they're fractions, I'm going to need a least common denominator. And what's my least common denominator? It's going to be cosine theta. The first term is already over the least common denominator. The second one isn't. So what's missing from this denominator? I need to have cosine theta. So if I multiply the denominator by cosine theta, I have to multiply the numerator by it too, because all I'm really multiplying by is a 1 in disguise. So now both of my denominators are cosine theta, so I can write both of my terms over the same denominator of cosine theta, and so I'm going to get sine squared theta plus cosine theta times cosine theta is cosine squared theta. And now, hopefully, when you see that numerator of sine squared theta plus cosine squared theta, you think Pythagorean identity. This is the most important of all the Pythagorean identities. So my numerator now, instead of sine squared theta plus cosine squared theta, I'm going to put 1 over my denominator of cosine theta. And what is 1 over cosine theta? It is secant theta. And that equals the right-hand side. So I have now verified this identity.